These are the trucks. Look at those things. You know, we have semis out there that haul 21 tons, and in Michigan they haul a lot more than that. And look at this. You had a driver, and you know, and the driver sat here, and this was a wood bed, and they didn't have any hydraulics on that thing. You loaded the load on the back end of the truck, so when you flipped the lever, it automatically dumped it. And then after it was dumped, then you grabbed a hold of a rope and you pulled it back down again and lashed it, and you went back and got another load. So, so that's the way they built things. Now, and I think that the way they loaded the trucks was they loaded the stone up here, and the truck drove under it, and then they dropped the stone into the truck. So.
These containers that you see on top, this is a container, like modern containers.
Where is this?
Yes, this one.
Here?
Up, yes.
Oh, there?
Yes.
I think, I'm not sure, but I guess in order not to have to wait on every single truck, I imagine they used a small crane, and that they took the stone from here and put it here. So then when the driver drove underneath here, it probably was a measured amount, and they could pull a rope or something, and it would drop probably 2 tons or 3 tons or 4 tons or whatever they had. I've also got some pictures. I didn't bring them, but for concrete construction, you'll get a real kick out of this. Instead of having a ready-mix plant that mixed the concrete and loaded it in a truck and came out on the job, they actually had a concrete plant that was on railroad tracks. So you went out and you laid the tracks down, and then the concrete plant moved along as you were mixing the concrete and pouring it. Well, when the trucks came in this way, they weren't in the right position to dump. So, so they had a thing on the railroad track that the little truck came up, and it drove up onto the railroad track sideways, and it was a little turntable. And the driver got out, or they may have had an extra labor. They physically turned the truck around, and then he backed it down the railroad tracks and dumped the stone into the skiff, and then it was lifted up into the concrete plant. And then the truck, you know, got off and drove away, but then when the next one came down, they had to turn that little guy around and back him into the plant. So this is kind of some of the new equipment that we use. Obviously, end loaders and hydraulic excavators. We're putting what's called riprap down in the ditch, and so we're carrying it down there with this piece of equipment, and then we're replacing it with a hydraulic excavator. Go ahead. We do use lasers. We use grade control. Years ago, you know, you had people on the back cranking. We don't use that anymore. This is what's called a ski. The electronic grade control is working off the ski. The amount of asphalt that is here is controlled by a laser that reads the asphalt in here. We have electronic GPS systems on our motor patrols and our bulldozers that work off satellites, and go ahead. And those are kind of funny because if they're working off satellites and you're working on a building site, you can be fine here, but when you get up next to the wall, if the satellite happens to be over here, the motor patrol can't pick up the signal. So so they're putting up more satellites to eliminate, or if you're working and you're going through a forest area and there's a canopy of trees, it won't pick it up. We'll go back on the other one. Our asphalt plants now, instead of having a lot of labor around doing various things, they're all controlled electronically. These are obviously 2 computer monitors, and you can just see vague outlines. It shows you what's going on in the asphalt plant at any given moment. And as a matter of fact, it talks to you in a human voice if something starts to go wrong. In other words, let's say that you've got a 200 horsepower engine on your dryer, and the amps are increasing on that engine. It'll actually come up and say, you know, alert, amperage is thus and so on engine number 4 or something like that, and then you can either send somebody out, or you can start to shut it down so you can check to see what's going on. So it's kind of fascinating. I want to spend a little bit of time talking about another project, and evidently the camera person down here or back here is an Indy 500 fan. We did not do this project, but a company I'm very familiar with did, Milestone Construction in Indianapolis, and the engineer on the project is a good personal friend of mine. But this is the Indianapolis 500, and and like every other piece of pavement, whether it's on a highway or a parking lot or a racetrack, after years it begins to wear out, it begins to be affected by age and traffic. And a racetrack like the Indy 500 or a NASCAR track, they're just not used for the races. They do a lot of testing. They test transmissions, they test engines, they test suspensions, they test brakes. So these tracks are used a lot more than just on race day. And obviously on any project, whether it's a project for the Department of Transportation or a racetrack, you have to determine what is wrong with the track and what needs to be repaired. And normally that's done by an engineering firm. It's not done by the contractor. Even IDOT may hire an engineering firm to go out and test the pavement, and they will do that by taking cores just like this. Go on to the next one. And that's exactly what they did. You can see it's not smooth and it's not exactly square. This is one that's been taken out of the pavement, and as you can see here, they have a different kind of asphalt here, different gradations, much bigger stone up here, and then smaller stone up here. The smaller stone will make a smoother surface. If this was the top surface, you could see it'd be very, very rough. But what is important in a mix like this is you have aggregate to aggregate contact, and that's true whether it's asphalt or concrete. You've got, in this particular instance, you've got asphalt cement between the individual pieces of aggregate, just like you would have cement in there. But look at all the aggregate to aggregate contact. So that's not going to rut very, very easily. Go ahead. Once the decision is made as to what is necessary, what repairs are necessary, they go in, and in this area they decided that had to be totally dug out, and that may have been dug out to take a sample so they could take it back to a laboratory, because you see the nice square edges. That's obviously been cut by a saw. They make it go back to the first. They make a determination, and then they once the determination is made, then they bring in in this particular instance, a rotomill machine, and what they're doing is they're grinding off the existing pavement. Now, a question was asked earlier about the work we did on I-70 and the work we do on other projects. During the evaluation process, money becomes a very, very important consideration. If we're doing, I suppose some of you would go to Champaign, maybe on Route 130. You know where Route 130 goes north out of Charleston. Okay, the volume of traffic on Route 130 would not justify the expenditure they did on Interstate 70, where they put 17 inches of asphalt. They would go out and they would test the pavement. They would test they would take traffic counts when you've seen rubber, look like rubber hose across the pavement occasionally. Those are traffic counters. They're trying to determine how many semis, how many automobiles travel that route per day. On a route like that, they would probably determine that it was cost effective to go in and take off 1.5 inches or 2 inches of the existing asphalt surface and then put it back down again. So the process that we're seeing here on the Indianapolis 500 is much the same that we would do on projects like Route 130, Route 45, Route 121, Route 16 between here and Interstate 70. I mean Interstate 57, and incidentally, Route 16. Our company was involved in building that when it was originally built. The old road was old Route 316 that kind of wanders up through the country, but We built all those bridges out there at one time, and we did a lot of the paving when it was originally concrete.